We're going to look at more hyperbolas today. So we're going to look at what happens when we need to put some coordinates on the point, or what happens when we've got a line intersecting a hyperbola. So let's just first of all sketch a graph and look at where they intersect. So the first example is going to be, where does the graph y equals 1 over x intersect with the line y equals 3? So you've got two choices here. You can do a quick sketch first of all. Well, we know that the graph 1 over x, so when we sketch a graph, we need to put on there the x and y axis. We need to get the general shape. We should try and put one coordinate on there. And you should always label the equations of the asymptotes as well, so that we understand. I often use a different colour for dotted lines, but it's really important to show that they are the asymptotes. Okay, so we've got x equals 0 here and y equals 0 there. Now, what I like to also do is put one coordinate on there. So what we're going to do is find out one coordinate for when the x value equals 1. What's the y value? So when x equals 1, what's y? Y equals 1 over 1. So y equals 1. So we have a coordinate now that I can put in, 1, 1. Let's try another one. When x equals minus 1. Let's do when x equals minus 1. When x equals minus 1, y equals 1 over x, so y equals 1 over minus 1, which is minus 1. So another coordinate we can place in there is minus 1, minus 1. So let's just plot those. 1, 1 is approximately here, and minus 1 is approximately here. Okay, so we have two coordinates. Now, let's have a look at where this line intersects with the line y equals 3. Well, we understand the line y equals 3 as a horizontal line through the point when y equals 3, because everywhere along there, I'll try and use a different colour, pink here, everywhere along that line, doesn't matter what the x coordinate is, the y coordinate is always 3. So that's the line y equals 3. Okay, and obviously this one is the line of y equals 1 over x. Got two lines. Now, we're going to look at where they intersect. So let's have a look. I'm going to clear some space here. All right, clear space. So what I'm going to do now is put these two equations equal to each other, because this one equals y and this one equals y. So it's like simultaneous equations. So I've got 1 over x equals 3. So solving this then, take the x up there, bring the 3 down there, tells me that x equals 1/3. So what that tells me is when y equals 3, x equals 1/3. Which means where the two intersect, you can see the hyperbola is two sort of separate curves. It only cuts one place, one point on this curve here, and the point where it cuts is when y is 3, x is 1/3. So this is the coordinate 1/3, 3. Let's have a look at a different kind of hyperbola. I'm going to clear some more space and we'll look at where that intersects the line 4x. So here we go, let's sketch. Let's do a quick sketch of what we have. So again, when you're sketching, I do always like to put those coordinates in, but I can just keep that the same because I already found that. So we know that was point 1, 1, and this one down here, point minus 1, minus 1. Okay, now, let's think about the line y equals 4x. Well, line y equals 4x, y-intercept is 0. So I also know it's a straight linear line, and I know that it's going to go through the origin. So let's just do that. Now, if I draw that line, oops, it's supposed to go through the origin. Hang on, let's make that. I'm a perfectionist, so I really need to redraw that. Okay, so I've now redrawn it, and you can see there that because the line goes through 0, 0, it cuts our hyperbola at two places, 1, 2. So we're expecting two solutions when we solve this simultaneously. So let's do the same thing. Let's put y equal to y, so 1 over x equals to 4x, and solve as if we're solving an equation. So I'm going to take the x over the other side, so we'll get 1 equals 4x squared. Divide through by 4, 1/4 equals x squared. So when I solve that, I'm going to get plus or minus 1/4, or square root of 1/4. So when I do that, the square root of 1/4 is 1/2, so it's plus or minus, so there's your two solutions, 1/2. So x equals either positive 1/2 or negative 1/2. Now, I know that's what the x values are, but we need to find the corresponding y values. So to do that, I'm going to substitute the x values into our y equation here. I can obviously substitute them into that one if I want. Far easier to substitute them into this equation. So I'm going to use this one here. So when x is a half, let's do this. Let's find y. Y equals 4 lots of half. So y equals 2. So I've got 1/2, so the coordinate is 1/2, comma 2. And let's look at the case of when x equals minus a half. Okay, so when x equals minus a half, substitute into 4 times minus a half, I get y equals negative 2. So the coordinate is 1/2, comma negative 2. So plotting those then, we go along 1/2 up to 2. So it's this point here. So this is 1/2, comma 2. And this coordinate down here is 1/2, negative a half. Oh, that's a mistake there because it is negative a half there. Negative a half down there and negative 2 there. Okay, write that in there. And that is how graphs of the hyperbola intersect ordinary straight line graphs.